All right, so today we're going to be talking about exponential functions and exponential graphs. So by the end of this, you need to understand what an exponential function is and be able to evaluate an exponential function. Then we're going to be talking about common bases of exponential functions, which are 10 and e, and graphing exponential functions. So the first video is really going to be focusing in on the actual function itself, and the second video will be focused on the actual graphing. So when we talk about an exponential function is a function with an exponent that's a variable. With an exponent that is a variable. And that's important. The exponent has to be a variable. It's not that there's just an exponent in it. To be an exponential function, that exponent must be a variable. So, an example of an exponential function is f of x equals 5 to the x power. Because again, in this case, my exponent is a variable. It is x. Or it could be something like g of x equals negative 10 to the x plus 1 minus 6, because again, my exponent is a variable. However, something like this, h of x is equal to x to the third minus 5x squared, this is not exponential, because we have exponents here, right? We have a 3 and we have a 2, but the exponents are not variables. So not exponential, because exponent not variable. Okay, so we're going to go over real quick how to evaluate these exponential functions. And they're actually really easy to evaluate. So this is the same thing as we were doing in our previous unit, right? We give you a function, f of 3. That means I'm going to put 3 in place of the x. So 4 to the x is really 4 to the third, and 4 to the third power is 64. Okay? So really simple here. There are some that are tricky that we're going to have to pay attention to. So f of 0. So we're going to do 4 to the x, which is really 4 to the 0 power. Now, in case you didn't know this, you might want to check it in or type that in your calculator. Most people want to say that it's 0, but really anything to the 0 power is actually 1. Okay? The next one, again, we're doing the f power again, so f to the negative 4. So this is 4 to the negative 4. Now, what you need to remember from first semester is that whenever we have a negative exponents are not actually allowed. So we need to really change that to get rid of the negative exponent, and the way we do that is we move it to the denominator, or to the opposite part of the fraction, because if it were in the denominator, we'd move it to the numerator. So this is really 4 to the 4th power in the denominator with a 1 on the top. So that'd be 1, and 4 to the 4th power is 256. This negative will be very important as we move forward tomorrow with exponential functions and trying to make them equivalent. So you're really going to have to remember this fraction thing. If I want to get rid of a negative exponent, I have to make it into a fraction. If I want to get rid of a fraction, we would do the opposite and make it into a negative exponent. Okay, next one, g of negative 2. So the g function is 1 over 3 to the x plus 1. So really, we're doing 1/3 to the negative 2 plus 1, which is actually 1/3 to the negative 1. Now remember from before, the idea is we're really distributing this exponent into our fractions. So this is really 1 to the negative 1 over 3 to the negative 1. And remember, we don't like those negative exponents, so we're going to go ahead and flip that to be 3 to the first over 1 to the first, so we can get rid of our negatives. And 3 to the first is 3, and 1 to the first is 1, so our answer would be 3. But again, you have to make sure you're really careful with that negative exponent. All right, next one, g of 3. Well, again, we're dealing with g, so it's 1/3 to the x plus 1. And in this case, my x is 3, so it'd be 1/3 to the 3 plus 1, which would be 1/3 to the 4th. And again, we just distribute that in. That's really 1 to the 4th power over 3 to the 4th power, which is 1 over 81. All right, so this is actually quite simple. The issue is you're going to have to be very careful with negative exponents, but not just with negative exponents, because here h of x is actually negative 6 to the x power. So you need to be careful here. Since it's not in parentheses, the only thing we're raising to the exponent is the 6, and the negative is kind of an aside on itself. So we can kind of view this as negative 1 times 6 to the x power to try to keep it separate in our head. So this is negative 1 times 6 to the negative 2. So again, we don't want our exponent to be negative. It's okay if the regular number is negative, but not if the exponent is. So this is really negative 1 over 6 to the second power. And 6 to the second power is 36, so it's negative 1 36th. Okay. Last two at the bottom are the k's, and these are fractions, right? So again, we're going to have to be a little bit more careful because fractions are involved here. So our k is 16 to the x power, right? And so since my fraction is 3/4, this is really saying 16 to the 3/4. Now again, from first semester, you're going to have to remember that the 3 is like the exponent and the 4th is like the root. So this really is 16 to the 3rd, and then we take the 4th root of it. Now, if I'm going to simplify this, we should try to do the root first, because that'll make life easier. So if there is a 4th root of 16, we should take it first, because that'll help us keep our numbers small. So 2 to the 4th power is actually 16, so the 4th root of 16 is actually 2. And then we take that to the 3rd power, and 2 to the 3rd power is 8. You could have cubed it first and then taken the 4th root, but you would have gotten a really big number, and we want to try to avoid those so that we can do these in our head more easily. Okay, next one. Again, this is k, so it's 16 to the x, and in this case, our x is negative 1/2. Right? So when I go ahead and I look at this, my first issue is that the exponent is negative, so we need to get rid of that negative exponent by putting it in the denominator. So this is really 1 over 16 to the 1/2. Now, I would remove that rational exponent by changing it into a radical. So we have 1 over, again, it'd be 16 to the 1st power, and then we would take the square root of 16. And again, to simplify this, I would try to take the root first. Well, the square root of 16 is 4, so this is really 1 over 4 to the 1st, which is just 1/4. So a lot of this was just reminding you about the process with negative exponents and rational exponents. In other words, exponents that are fractions. Okay? Okay, so we have done the first two on our objectives, which is understanding what an exponential function is, evaluating them, and now we're going to do the third one, which is the common bases. Okay, so there are two common bases when dealing with exponential and logarithmic functions, and we're going to be dealing with logs in the next couple of days because exponents and logs, exponential function and logarithmic functions, really are related to each other, and they act sort of as inverses to each other. Okay, so our two common bases are 10 and e. Now, if you don't know what e is, it kind of acts like a pi in a way, okay, where pi is a specific number, 3.14159, so on and so forth. E kind of acts in that same fashion. And if you look down here on your calculator, there is actually an e right here over this ln. It says e to the x. So if you type in that e, and let's just type it to the 1st power so we can see what that number is, it is 2.71828. Now, pi was created to deal with the ratios involving circles and area and circumference. This one is more of a statistical basis, but it's really a lot like pi. So whenever we're working with it, we're going to use e on our calculator just like we would use pi, because this isn't really even the actual number. It does keep going and going and going. E actually is going to be something you use a lot in calculus as well, and I'll talk more about it then. All right, so even with these common bases, the steps are still the same. We're still going to use the function to evaluate the problem, but now when we find f of 3, well, f is e to the x power, so we'd have to do e to the 3rd, so we're just going to go to our calculator like we did before and use that e to the third power, and we're going to estimate it, so it'd be 20.09. Okay? H to the third, well, my h is 10, so this is 10 to the x power. So this would be 10, oops, sorry about my messy handwriting, 10 to the third power. And 10 to the third power really is just 3 zeros, right? So it's 1,000. Okay, then we get to our f to the negative 4, so that's e to the x, which is really e to the negative 4. Now again, you need to remember that we don't like negative exponents, so that's really 1 over e to the 4th. So then we'd have to do e to the 4th in our calculator. And e to the 4th in our calculator is 54.59, so it's really 54.6. Now, I will never want to see a fraction that has a decimal in it, so really let's just give the final decimal answer. So 1 divided by 54.6 is going to be 0.018, or yeah, 0.018. But we only do that because in this case my fraction was a decimal, whereas before we were able to find exact answers. With e, you're never going to be able to find an exact answer, so you could just type in e to the negative 4th and go straight here, and that would be fine. But realize when we're dealing with other numbers that aren't e or pi, I would expect to get an exact answer like this and not a decimal. Okay? And the last one, h to the negative 4, so again that'd be 10 to the x, which is 10 to the negative 4. We don't like negative exponents, so we'd put it in the bottom. And 10 to the 4th power just means I would have 4 zeros at the end, so 1, 2, 3, 4, so it's 1/10,000th. Okay? Now, for tomorrow, you're going to go ahead and you are going to try these on your own. So these last problems you're going to do on your own, and we're going to check them together in class tomorrow. Now you're going to need to start the next video to learn about graphing.